Hi there, it's Diane, and welcome to my basement. Today, we're on page 67 in your workbook. We're going to be learning about prime factors and multiples. So what's a prime factor? And what does that have to do with multiples? Let's look. A factor is a number that is multiplied by another number to obtain a product. If it is a prime number, we say that it is a prime factor. So you need to remember what prime numbers are. On page 63 of your workbook, it says that a prime number is a number that cannot be represented by equal groups of 2 or more because there's a remainder left over. So our prime numbers, remember, are not 1 and they are not 0. But our prime numbers under 10 would be 2, 3, 5, and 7. So your prime numbers, the first 4 prime numbers are 2, 3, 5, and 7. You can't put the number 2, 3, 5, or 7 into equal groups of 2 or more. Does that make sense? Great. Numbers can be decomposed, so broken down, into prime factors with the help of a factor tree. So this is a factor tree. Here is how to proceed. So here we have a factor tree, and the fact that they're trying to, the number they're trying to factor is the number 18. The first thing we have to do is we need to find 2 factors of the number. So what 2 numbers do you multiply together to get 18? Well, here they show us that they multiply 2 times 9. It says, if possible, find 2 factors for each factor obtained. So, can we find 2 factors for the number 2? No, because it is a prime factor. So we leave 2 alone. Then we look at 9. Is it possible to find 2 factors for the number 9? Yes. 3 times 3 equals 9. You need to continue in this manner until all of the numbers obtained are prime numbers. 2, 3, and 3 are all prime numbers. So, the prime factorization of 18 gives us 2 times 3 times 3. I'm going to pause a little bit, let that sink in. Does that make sense to you? We made a tree, a factor tree, like branches, right? And we're breaking down the number. We're taking the number 18 and we're trying to break it down into the prime factors. All of the factors of 18 that are prime numbers. So 18 we split into 2 times 9. We brought down the 2 because that's already a prime factor. And then we took the 9 and we split the 9 into a 3 times 3. And then we put them all together. 2 times 3 times 3. 2 times 3 is 6. And 6 times 3 is 18. That's all you have to do. Just breaking down or decomposing a number into its prime factors. Multiples. So a number is a multiple of another number if it contains this number exactly 0, 1, or several times. For example, let's look at the number 12. 12 is a multiple of 6, since 12 contains exactly 2 times the number 6. 6 times 2 equals 12. To find the multiples of a number, multiply it by 0, 1, 2, 3, 4, and so on. If I asked you what the first 6 multiples of 6 are, you would say, you always start with 0. This is what the little monster over here is saying. 0 is a multiple of all numbers. Since all numbers multiplied by 0 give us 0, so we always start with 0. We start with 0. 6 times 0 is 0. Then we go to 6 times 1 is 6. So we have 0, 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. So you would have the first 6 multiples of 6 are 0, 6, 12, 18, 24, 30. Another way of looking at it is always starting with the number 0, then add 6, add 6, add 6, add 6 more, add 6 more. Just keep adding 6. The multiples of 6. Let's try some practice. All right. We're on page 68. Complete the factor tree for each number. Indicate the result of its decomposition into prime factors. What does that mean? Well, remember, these are the factor trees. A tree is when you break down into its branches. A tree has branches. So we're just going to fill out this chart. Indicate, that just means to write down the result. Write down the answer of its decomposition. We're getting the number smaller and smaller until we have prime factors. Remember that prime factors are our prime numbers, like 2, 3, 5, and 7. I think it would be really important to remember the first 4 prime numbers, 2, 3, 5, 7. Let's see how that goes. 2, 3, 5, 7. All right, so let's look at 30. 30, the 2 factors that make 30 are 6 times 5. It could be another one. It could be 3 times 10, but they chose 6 times 5. 5 is already a prime number, so they just carried that down. For 6, they multiplied 2 times 3. So we have 30 equals 2 times 3 times 5. Let's check 70. So 7 times what number is 70? 7 times what number is 70? 7 times what number is 70? 10. I heard it. 7 times 10 is 70. Well, let's look at the number 7. Is that a prime number? Is it 2, 3, 5, or 7? Yes, it's a prime number, so we just carry it down. Is 10 a prime number? No. So, what 2 numbers equal 10 when we multiply them together? 2 times 5, or 5 times 2 is fine as well. So we have 7 times 2 times 5 are all prime numbers, right? Well, they're prime factors. 7 is a prime number, 2 is a prime number, and 5 is a prime number. So we're done. 70 equals, you can put them in order, so you can say 7 times 2 times 5, or as they get increasingly bigger, you can write 2 times 5 times 7. It doesn't matter the order. 5 times 2 is the same as 2 times 5, and 5 times 7 is the same as 7 times 5. You can go in any order. The book has it 70 equals 2 times 5 times 7. They just wrote it in increasing order. So they started with the lowest number, 2, then they went up to 5, and then they went up to 7. Let's look at B. 25. B is a unique number because it is a square number. Do you remember that? So we know that 25 is 5 times 5. Do we have to do any more branches? No, because 5 is a prime number. So 25 equals 5 times 5. You already have it finished. That one went by fast. You're getting very good at this quickly. I'm impressed. Let's look at 21. 3 times what number is 21? 3 times what number is 21? This is why it helps to memorize your multiplication tables, because some people, they just know it right away. Other people, it takes them a while. Now, if it takes you some time, that's fine. Take your time. Some people, they like to go straight to the 5s, so they know 5 times 3 is 15, and 15 is less than 21. So they go, okay, it's not 5, so they go up to 6. So they go 15, 16, 17, 18. Oh, it's not 6. Let me try 7, 18, 19, 20, 21. That's it. So 7 times 3 and 3 times 7, they both equal 21. We know that 3 and 7 are prime numbers. So 3 times 7 are prime factors. So 21 equals 3 times 7. That's it. That's how you make your prime factorization trees. And that's how you decompose a number. You're learning so much today. Let's look at page 69. Make the factor tree. Now they want you to design the tree for each number. Indicate the result of this decomposition into prime factors. Now they're going to give us some sample answers. The reason for that is because you can do it different ways, but your answer will always be the same. I'll show you what I mean. Let's look at 20. So, 20. Some people, they might start off and say, oh, I know right away, 20 is 2 times 10. It just stands out quickly. 20 is 2 times 10. They know that 2 is a prime number, but 10 is not. So you need to break down 10. Decompose it. 10 is 2 times 5. I know that both 2 and 5 are prime numbers, so I'm done. 20 equals 2 times 2 times 5. And you can actually circle them if you want. 20 equals 2 times 2 times 5. But maybe the person next to you says, hold on, I didn't get 2 times 10. I did it a different way. And I would say, well, how did you do it? And then they would say, well, I know that 20 is 4 times 5? And I know that 5 is already a prime number. So I went to my 4, and I knew that 4 was 2 times 2. And so I got 20 equals 2 times 2 times 5. 2 times 2 times 5. And then we would look back and say, yeah, that's what I just said. 20 equals 2 times 2 times 5. And guess what? They are both correct. 20 equals 2 times 2 times 5. So it doesn't matter if you went 2 times 10 in the beginning, or if you went 4 times 5 in the beginning. Your answer should still be 20 equals 2 times 2 times 5. Great. Let's look at F. 56. Ooh, that's a big number. 56. Can you see that? 56. Let's see. 5 times 11 is 55. What two numbers multiplied together equal 56? I know 7 times 7 is 49. And then if I added 7 more, I would get 56. So I know that 7 times 8 is 56. I know that 7 is a prime number because remember, 2, 3, 5, and 7 were my prime numbers before we hit the number 10, right? They're my first 4 prime numbers. 2, 3, 5, and 7. Remember those. So we have 7. We look at 8. We can break 8 down into, decompose 8 into 2 times 4. So 2 is a prime number. But look at this. I can break 4 down into 2 and 2. There's a lot of 2's there. So 56 equals 7 times 2 times 2 times 2. But some people like to go 2 first. So it can be 2 times 2 times 2 times 7. 2 times 2 times 2 times 7. Let's see if we got it right. 56 equals 2 times 2 times 2 times 7. Yep, we got it. Are you ready for some more? I want to see if you can write the first 7 multiples of each number. The first 7 multiples of each number. So, they start off with the number 7. What is the first multiple we always write? What is it? 0. Yeah, you're right. It's 0. We always start with 0. Okay, so we have 0. Now, what's the next multiple? Well, I just do 0 times 7 is 0. 1 times 7 is 7. 2 times 7 is 14. 3 times 7 is 21. 4 times 7 is 28. 5 times 7 is 35. And 8 times 7, were we at 8? Oh, we're at 6. 6 times 7 is 42. Make sure they're in order, right, when you do it. So, 7 times 1. Well, we always start with 0. Okay, let's get that straight. Always start with 0. 7 times 1 is 7. 7 times 2. Did we get it right? Have I made a mistake? Nope, 14. 7 times 3 is... Dun, 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 21. 7 times 4 is 28. 7 times 5 is 35. And finally, 7 times 6 is 42. So those are the first 7 multiples of 7. Try to do the first 7 multiples of 3, 8, and 9. Let's do one word problem, and then I'll leave you there. Leon and Lena, or Leon, let's go with Leon. Leon and Lena, I wonder if they're twins. They begin training today for the space rocket race. Oh, that sounds exciting. Leon trains every 3 days, and Lena trains every 4 days. Ooh, I understand that. In 15 days, so they show us days 0 to 15. In 15 days, how many times will Leon and Lena train on the same day since the beginning of their training? So since the beginning. Let's look. So if they don't go day 0, this is our starting point. So Leon, he trains every 3 days. So I go day 1, day 2, day 3, and I'm going to put an X. He's training on that day. Then I count 3 more days. 1, 2, 3. I see a pattern. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And 3 times 5 is 15. So he is going to train on days 3, 6, 9, 12, and 15. Lena trains every 4 days. So I'm going to find the multiples of 4. Start at 0, and I'm going to go 4. 4 times 2 is 8. 4 times 3 is 12. And 4 times 4 is 16, so it's not here. How many times will Leon and Lena train on the same day since the beginning of their training? How many times will Leon and Lena train on the same day since the beginning of their training? Well, I know they're both going to be on the 12th. Since the beginning. So perhaps the 0 counts. Let's see what the book says. This one's tricky. I know that they both train on day 12. Okay. In 15 days, Leon and Lena will have trained twice on the same day. They're counting day 0. Now, I'm guessing this is like a training day. And they say since the beginning of their training. So they're going to count day 0. That seems a bit tricky. But okay. They're counting day 0. And they're counting day 12. So in 15 days, Leon and Lena will have trained twice on the same day. Day 0 and day 12. I would like to go into outer space. That would seem pretty cool. I'm not quite sure I would go to Mars, but maybe circle the moon would be a little trip I would go on. All right. Hopefully you've learned a little bit about decomposing numbers into their prime factors. You've learned about multiples. Stay curious, and I will see you next time.